Good morning, class. Today, we are going to talk about how to apply those kinematic equations that we discussed earlier. And hopefully they pop up right now. So if I go back to our kinematic equations, over here, level 3, we want to discuss how we're going to use our kinematic equations to describe a projectile that's being launched at an angle. So remember, we used our trigonometric functions here, sine and cosines. And we came up with these generalized formulas. So the generalized formulas are going to be utilized in this particular case. We used them last time when it came to the initial velocity, but the angle was 0, if you remember. I believe that is right here. Nope. See, right here, initial velocity. So the angle happened to be 0 right here. Okay, and so cosine of 0 was just 1. And the sine of 0, the angle is 0, the sine of 0 happened to be 0. So that meant that this piece went to 0 for the displacement in the y direction. So let's just close this down. Let's open up a new document. And I just want to call this one predicting the range. Well, let's just say predicting. And I'll put L4, because this is going to go in a level 4. So let us first write our equations down for, and I don't want to use blue, I definitely want to use black. So we have xf minus x initial, this is our displacement in the x direction, equals to the product of the initial velocity, which we just calculated, times cosine of theta and t. And then we're just going to have plus 1/2 ax t squared. That's our first equation. Our second one is here. Displacement in the y direction equals to the product of the initial velocity, sine theta, and t, plus 1/2 a sub y in this particular case, the acceleration in the y direction, times t squared. So let's analyze equation number, in this particular case, let's just call it 1, since we're treating a new experiment. So in this particular case, all of the net forces, okay, this is how it's going to look. We're going to fire a ball like so. It's going to have an initial velocity. In order to think about or consider the x displacement or the x direction, we have to know our initial velocity in the x direction. And the same will go for the y direction. Okay, so we need to know those things, and we need to know this angle. This is something that we'll need to be able to measure. So the first consideration, let's say that we're going to keep it generalized for all angles, but the first consideration is, will this thing experience a force in the x direction? So will it experience a force in either the positive x or the negative x direction? And the answer in this particular case is no. Let's just say that it'll experience a force, but it's negligible. It's so small that we don't have to consider it. All right. So this is our x direction. So if that is the case, we can just say, well, since there is no net force in the x direction, or all of the forces are balanced, this implies that the acceleration in the x direction is 0 as well. And thus, our last piece here, it's going to be 0. So we can write our displacement like so. So this is saying that if we know our initial velocity, and we know the angle of launch, and we know the time of flight, we can predict the displacement for this projectile along the x direction. That's what it's saying right there. So how are we going to get time? We already know initial velocity. We just calculated it in the last video. It's like 3.1. The angle that we're going to choose will be 20 degrees, but we're not limited by that, but we're going to choose 20 degrees. And then, let me see here. We need to know our time. So how are we going to find our time? We're going to find our time looking at equation number 2. So if we analyze the acceleration, we're looking at what's happening in the y direction. So we know that sine of 20 degrees is not going to be 0, so this piece won't go away like it did last time. But the acceleration, what will this object accelerate? The way you know that it's going to accelerate in the y direction is that this ball goes up and then it comes down. Remember Newton's first law. Newton's first law basically says an object that is at rest tends to remain at rest unless a force, an external force is applied to it. Or an object that is in motion, let's say it's in motion in a straight line, will remain in motion in that straight line unless a force, an external force, acts upon it. So we know that this object is going to just go up and then come down. So our acceleration will not go away. So in this particular case, the acceleration in the y direction is only going to be a negative g. And we discussed this last time. And where g is just 9.81 meters per second squared. Okay. So let's go ahead and analyze the next equation, which is yf minus y initial. This is something that we're going to be able to measure from our video physics. This equals to the initial velocity, which we know, times sine of theta, which we know because we know theta. It's going to be 20 degrees, times t, which we don't know, minus 1/2 gt squared. Okay? So g we know. T is the only thing that we will not know. So let's reorganize this equation. And I want to show you how we're reorganizing it. Have you guys ever heard of quadratic equations? What is the solution to a quadratic equation? Or what can a solution be to the quadratic equation? Let's say that a, b, and c are all constants. Okay, just means that there's some value or coefficients, however you want to look at it. And t is a variable. So that means it can change. The solution to this quadratic equation is the quadratic formula. So it's just going to be t is equal to a negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All we need to know is a, b, and c. In this particular case, and I'm going to rewrite the equation first, we have 1/2 gt squared plus initial velocity sine theta t minus the displacement in the y direction, all equals to 0. So in this particular case, this piece is a, one half g is a, v naught sine of theta is b, and then a negative displacement is c. So we know how to measure each one of these values so we can calculate t. And that's what we'll be doing in the theory. Okay? This is how we're going to find it. Now, there are two solutions to every quadratic equation. But in this particular case, we're just going to use the negative solution. Okay? Well, you have a negative b minus, that's the one we want. We're not going to use the plus because it's going to yield a negative time. And that is it for the theory.